Thank you very much, Bogdan. I really appreciate everybody's time and effort today. If you want to hold your questions to the end or put them in the chat, we'd be more than happy to ask them. TSI has been a reseller and solutions provider for Keysight and Eggplant products for a number of years. And we're very happy to bring this new way of using Eggplant. One of our customers as a use case to use AI in more explicit ways to help with what we're doing these days in the test automation development space. No further ado, we'll get going. I'm going to be your speaker for most of this, and we'll switch over to John, one of our main solution architects, who's actually built all this great AI automation, and he'll walk you through some of the caveats and issues with that. TSI is also available to help you if you want to reach out to us on how to implement an AI program with Eggplant. We're more than happy to show you what we did in this presentation as well for your particular use cases. So in a summary here, we're going to talk about SenseTalk, the solution within Eggplant of coding. It's a great coding language, and it's a very high-level coding language, right? And we took an approach of building handlers, and we'll talk a little bit about the differences between manual code generation and AI code generation. We'll talk about the time, quality of that. We'll even go through the comparisons on different AI tools that are out there and why it outperforms, and then your key takeaways and next steps. So let's talk about the challenges of manual SenseTalk coding. Well, first of all, it takes a little while to train people how to use Eggplant, right? And then writing handlers manually. A handler, basically, from our terminology, is basically a subroutine or a procedure that handles a particular use case of using SenseTalk that can then be used in a more complex logic, right? So we use that as a library of boilerplated coding implementations, if you will. So when you do that, the developers usually have some standards, usually have to do certain types of syntax checking, and we want to make sure that it's a reusable handler for others to use. What happens, though, is that we have different engineers. Because Eggplant has lots of capabilities, they format and structure the code differently. We get irregular headers. We have all sorts of different parameter handling methods, and it becomes more unique. So if I'm trying to juggle all that logic and compliance and standards, you get programming fatigue, right? And that's where programmers tend to put in errors, right? Human people make mistakes. We see things where they aren't and see things where they shouldn't be. That happens all the time. So we miss these validations. We miss the incomplete logging. We skip some error handling. Those are things that typically we all do because no one wants to do that error handling. We don't want to handle all the different logging potentials and possibilities. And you've got to have review, right? So we have to go into design reviews and correction cycles to do that. Because it's inconsistent, peer reviews are more time consuming because they have to explain how somebody decided to code that particular module. So when we do those design reviews, we go back and forth and there's more time spent doing that. And then it's not very scalable. Manual development's not scalable across multiple engineers or projects. We have to train new engineers on our compliance, our syntax methods, our boilerplate methods, because there's really no enforced format, if you will, on how to do that. So these new engineers have to come up to speed, and it takes time and effort to do that. And then because they're manual, sometimes we have to refactor things before it's production ready. So that delays our timelines, consumes basically senior engineering time in a lot of cases. So these are just challenges that everyone faces in the manual world. I guess I should click that out of the way. How do I hide this screen here? Hide annotators. Hide video panel. Nope. Okay. All right. So how does generative AI work to do this, right? To assist it. So basically, the first thing we can do is generate these handler templates. So the engineers can not have to build these repetitive boilerplates, right? It saves you time and effort from doing that because it builds what we call the code scaffolding to do that. Because each handler includes logging and validation and consistent formatting because of its AI style, the style drift does not happen across developers, right? Because everybody's using the same style formats, the same logging, same validation, and consistent formatting. So standards are enforced automatically. We get the error reduction, right? Because we have explicit flow controls for our different if then else's and other loops. Common mistakes, missing validation, incomplete logs are gone because we're not introducing those or building those manually. We're building it correct by constructive AI methods. It's also fast. If we manually build a handler, it's 20 to 45 minutes to build that code. AI runs at machine level speed, and it's usually 2 to 15 minutes. So we're generating these things, and then sometimes even generated in seconds. And then obviously we focus on what the handler should do rather than recalling syntax. So it reduces that mental load that the engineer would have to do and have to focus on. And now it's scalable, right? So we have multiple engineers generating handlers in the exact same style. So now our automation portfolio becomes very consistent with the format, how things are done. They become more readable as well and more reusable, which is even more important. So now we're parameterizing these handlers instead of hard coding values, which every engineer has always done in the first pass. You always tend to hard code stuff and not put variables where you should, and then you have to go back and do that. So now we're cutting down on that up front. So we're cutting down on duplicate code and certainly the long-term maintenance issues in these environments. Okay, so I think at this point, John, is where I turn things over to you. Is that correct?
Yeah, that sounds right. I'm ready.
All right, so we're going to hand this off to John Koenig, who is our Senior AI Applications Test Automation Engineer. And John's going to take it from here.
Okay, go ahead, Chuck. Move to the next slide. So preparing for the AI to write code, what we need here, and Chuck talked about this a little bit, is a template. We design a template where we tell the AI model that we're using exactly what we want, and more importantly and more common, what we don't want. Go ahead and advance it, Chuck. So we establish these standards where we have this strict template saying, here's how I want the code to be returned to me. Here's the different parameters I want to use, the behavior, how I want everything to be structured together. So we create these guardrails, and these guardrails, basically we're saying, I want you to return pure sense talk. I don't want Python, I don't want Java, I don't want any other programming language. I just want sense talk back. And that is something I found with AI that you really have to reinforce, because it quickly, most of these AI models seem like they're made to return common code types, and sense talk is not a common code type for people. So you'll see a lot of Python and other languages pop up in places. So we want to create that guardrail of the things we don't want. And then we want to build reusability. We want to tell AI that we want all of our handlers to be parameterized so we can use these anywhere else, across different test cases, projects, multiple times in the same test case. And then again, consistency. So we want to make sure that the output that we get from AI of every handler, that they all are structured the same, they have the same types of comments, everything is in line. So if someone looks at any two handlers together, they can understand easily what's going on. And because of this consistency, anyone using this template with AI models to generate your handler are going to get the same output, right? So you don't have different output for different developers. And then documentation, right? We want to make sure that there's comments on these handlers of how they work, to explain to anyone who didn't write it. They can quickly read the comment section and understand how the handler works, how to use it, and I'll show an example of that next. And then refinement. So when you build this template, you're going to find that you're not going to just have one template. You're going to provide it a template with all of your instructions. It's going to give you your handler back. You're going to look at it, it's not quite right. You're going to refine your template, resubmit, get the code back, and you're going to go through this process where you're going to, every iteration of your template is going to be a little bit better until you get to one that just works for what you need. So there is some trial and error that is involved here for getting this set up, but once you do get it set up, you're going to get great results back quickly. Okay, next slide. All right, so this is just an easy example of what a user would write. Okay, so we're going to click a button, and then we're going to wait for that button to become active. So once we clicked it, it went gray. Now we're waiting for that gray button to turn blue again, or whatever to be active is, and that's what the active image is. So we're just running through repeat loop, waiting for that to become active, and then we're going to click it again, and then we're going to end, right? So there's hard-coded values, there's no description, there's no parameters, there's no error handling, there's no logging. If it works, it'll probably do the job and it'll probably work fine, but this is just a simple example. If you get more complex handlers going, we can't stick with this. This isn't going to work later on. Other people aren't going to understand what's going on. So go ahead, next slide. So by writing this template, in the template, we told it, this is how we want our comment section to be. So at the top of every handler, there's now a comment section where we have a purpose. We have a usage of how to use the handler. We have an listing of the parameters and a definition for each parameter, what it should be. We have the behavior that's expected from our handler. We have an example use, and then we have some notes, just things, caveats to remember when doing this. So we've given this template all of this guidance of what we do want and what we don't want, and so we get this comment. Go ahead for the next slide, Chuck. And so we get this code back now. So at the bottom after that comment section, now we have the code, and you can see from the code now it's more complex. There's error handling, there's logging, there's it's reusable. There's parameters coming in. We have all the things that we need to be able to use this in other places. Easy to understand, consistent output, right? We have the explicit flow control, we have the logging, transparency. Everything is here for this to work, and it only took a matter of minutes to get this output from AI. Go ahead, Chuck. So what we have is what we found, manually creating a handler, 20 to 30 minutes. And this is where you're going through and you're manually going through and selecting your images and putting in your code of what you want to happen when images are clicked or found on screen, different things like that. 20 to 30 minutes. And usually when that's done, it might be kind of messy. It might not have any commenting or error handling. It's just going to do that task that you wanted it to do, right? And if it's something complex, right? If you have a handler that's, multi-parameter, a lot of different loops, if then else statements, things like that. If you have one that gets to that point, it can take much longer. AI assisted handler, now we're taking away my need to do all of that extra coding, because now I can say to AI, I want a handler that when I click this image, I expect this response. And when this response happens, I want you to click that image again. I can just say that in simple terms. And because I've already provided my template of all the do's and don'ts that I want it to do, then when I submit within just a couple of minutes, I'll get that handler right back, as the example that we showed. And then a complex handler, a little bit longer. You're not always going to get a 100% usable handler the first time you submit. It might give you the code and you'll put it into SenseTalk and you'll run the check script and find out that there's a word in there that is not recognized by Eggplant. So you'll have to go back, update your template, go back to the AI and say, hey, this word used, we can't use this. We need to do pure SenseTalk. Give it a reminder, come through and get it again. So there's a little bit of back and forth sometimes, so it can take a little bit extra time, but it's still much faster than doing it manually. Plus, when you get it out, you get your comment section, you get consistent code. So overall savings, we found, yeah, simple handlers are 10 times faster. Conversions are fast as well. Complex handlers are all fast. Every way you look at it, it's going to beat manual because of all of the extra that it does that a person doesn't have the time or isn't going to take the time to do each time. So again, a graph of that example. Go ahead. All right, so we're going to compare some models here. In our environments, we work with some customers that are in offline environments, and we have some customers that are online environments. So whenever you can use online, right, it's going to be the best because you have access to documentation from Eggplant. You have access to the internet, things like that. So online GPT models are going to be your best bet when using this type of programming when you have your own template. Both cases, you still need that template. You still need those guardrails in place to tell it what it can and can't do. Offline LLMs, they're going to be slower. They're usually a couple revisions behind online. They might not get updated very often. A lot of times they don't have memory between chats, where the online you can have several chats with, and it remembers kind of the conversation that you've had through multiple chats, whether they're relevant or not. Offline, each chat is its own sandbox, not shared anywhere, which is great for security, right? So you have a secure chat that's not going anywhere. It's not being used to train the model. No one else is going to, have access to this. But because of that, it's going to be slower. It might not have all of the programming knowledge depending on how it was made. We might not have control of how the offline LLM was made. We just have to use what's available to us that the customer has available. And so in some situations we've had, depending on security rules, that they time out and log you out every 10 minutes and you have to go back in and start over again. So offline in some cases, they're not the best, but if it's the only thing you have, it is still faster and more consistent than manual coding. Go ahead. So for our customers that we work with, we have two offline available. We have the U.S. Army Camo GPT and the U.S. Air Force Nipper GPT. Both of these work great. I will say if you have a chance to use Camo GPT, it is faster than Nipper GPT, and I've gotten better results with SenseTalk from it. So there's just some details here of what's available to use. Again, not shared. Everything stays secure. You can still generate good code with them. Not as great as online, but still better than manual. Go ahead. And then for offline, for Nipper GPT, there's different models available within it to use, right? So you can read some details about it. We found that the Anthropic Claude 3.7 Sonnet has given us the best SenseTalk accuracy, stability, code that works 95% of the time and doesn't need much rework. And even if it does need a little rework, within that same chat, we'll update the template, we'll give it the new instructions of why its previous code didn't work, and then we can get more consistent results each time. We just have to make sure that we reuse that same chat each time unless we're ready to do a new template and start a new chat with it, because it does not remember anything. Nothing is shared between different chat messages or different chats in it. Okay, next.
Okay, well,
back to you.
Back to me now. Thank you, John. That was a great overview for us. Thank you so much. All right, so why offline AI still outperforms any human coding? And this is generally just in AI in general. I mean, it's going to produce this consistent structure and formatting across all your handlers. A lot of design groups and software development groups, compliance, standardization, structured environments for groups, and being able to have those standards and documentation automatically applied is going to reduce tons of errors and omissions and give you consistency across those things. It shifts the effort of writing these boilerplates to focusing on the entire test logic. So you're basically raising the level of abstraction of what your test engineers are building is much higher and using them in a much better and more efficient way. Now these parameters are completely reusable, parameterized for you. Instead of doing one-offs, now you manage less code. There's more comprehensive code, and you're covering more of your product, more of your test automation goals and standards. It speeds up your reviews because now the code's predictable and uniform. People can understand it. Consistency across all aspects of the design cycle of building test automation code. Takes our rework time, goes down, even if the initial generation can take longer, but typically it won't. It takes much less. So one of the things that we find is looking at the lifecycle management of contractors. And reason we look at this from our perspective is we do a lot of government work, and there's basically contractors that come and go across different projects. And this may be true of your organization as well, where we have to deal with the lifecycle management, right? So if we bring in a new contractor is hired for a defined period, it could be 3 months to a year, how do we bring them into the project and make sure that, that's set up and clearly defined? How do we onboard them, right? So we provide the AI coding templates and standards for them. And so there's, minimal ramp up time needed to build that enforced consistency from the generative AI perspective. And then we assimilate them into the environment, right? So now the contractor can immediately integrate into the team. We're all using the same AI-driven process. And then the output is always uniform, regardless of the contributor, because we're using all the same structured templates. So we can actually go through the organization, retains this continuity. Basically the execution, we're generating the code with AI following the project templates. They're parameterized, of course, and then we can do handoff between the different folks that are available out there. There's very little cleanup, and it's already aligned with your standards. And then that documentation is inherently ready for documenting what was done for future use. And then the exit, the organization retains the continuity, avoids knowledge loss, and keeps the AI-driven quality that's provided by the AI-driven process. Got a couple things out of order there, but basically contractor departs, but the output remains fully usable without question. So it becomes great. So what are the key takeaways that we've added from this webinar, if you will? We can basically use AI to reduce our time, errors, and rework across our test automation development. These offline models even outperform, but the online ones do even better job through the manual coding over manual coding techniques with the consistency and standards that you want. We turn these scripts into documented reusable assets that can scale across projects. Just by using the AI provides that ability for us. We track all the metrics to make the ROI visible and measurable, of course. And then we revisit, and we can take our old code blocks, old code blocks, and use AI to make them more scalable, more reusable, and save on development time, and increase the ability to document them and make them consistent as well. And then we can do hybrid workflows, offline for security, online for speed, to maximize the value of your test automation environment. And basically, that's the end of our presentation. If you'd like to reach out to us to get you started on your AI journey, we're available to show you our techniques under consulting contracts as needed, or give us a chance to do a POV, a POC on using AI in your environment to show you how much you can actually gain from it. So with that, Bogdan, and thank you, John, for your input on this environment. We can turn this over to any questions or comments that you may want to ask us at this time. So
I think we have a question. Somebody was asking what AI tool is being used in these examples. I think you've already discussed it, but if you want to underline, that would be great.
John, you want to answer that one for us?
Right, ChatGPT 5 for the online use, and for those that were generated within the slides, that was using Camo GPT.
Okay.
Perfect. I think we already have answered this question. I'm not really sure if there are any more questions from the audience. We'll give a few more minutes to see if somebody has.
Just a quick comment here is that this project was developed for a DoD project. So it's being used in the military at DISA specifically to automate and deliver some pretty amazing ROI for the internet testing groups there.
Sounds good. Perfect. So just a quick question. If somebody wants to reach out to you directly, I see. Oh, perfect. Yes, I see now. You put your email. Perfect. And as mentioned, you'll also be receiving a copy of this recording. So feel free to reach out to any of us if you have any questions, or directly to Chuck for more details on the presentation. I don't think
there's also some information on our website. There's a blog, a recent blog out there that talks about this entire process, what we did. So you're welcome to check that out on our main webpage. That's all I have.
Sounds good. Maybe we'll include the link to the blog in the follow-up email, and everybody will have a chance actually to read that blog then. Perfect. We don't have any other questions for the moment. So if any of you has any questions, please do feel free to send them over to us, and maybe we can do a follow-up session with more details. And with that, since we don't have any more questions, we'll end the webinar here. Thank you, everybody, for attending this webinar. Thank you, Chuck, John, and Steve for your participation. And yeah, looking forward to the next one.
Thank you all. Take care.
Thank you.
Thank you.